Okay. So I'm glad people who have already graduated are listening to this, but you're welcome. Um, so how these work normally is that I will kind of post the test. I actually just emailed you this version of the test. So if you want to kind of try this before you see me do it, you're welcome to do that. All right, that's just in your email. But the way that this works is I'll kind of just gradually go over the test and I'll review as much as I can um, as I do it. All right. And as we have questions, just either put them in the little chat bubble or email me. I think it's probably easier to just put it in the chat. But if you want to email me, go for it. I'll be kind of keeping an eye on my laptop or phone. Um, but I want you to ask questions. That's kind of what this is for. This is like the last um, point of contact that you have with me before the test. Obviously, I'll be available tomorrow morning, but this is normally when people study for it, so I figured I would do this now. All right. Um, so test tomorrow is over pretty much everything we've done with quadratics. I highly suggest you have a calculator in hand, so you can kind of go over how to do this as I do it. Unfortunately, I cannot show my laptop on screen. Um, I have an attachment that would allow me for that, but I don't. It's not working. So there's that. Um, anyway, um, there is a little bit of a delay, all right, in me actually saying this, and then me being able to read your chat and all that. So if you have a question, just be patient with asking it. I might also try and explain everything before I actually answer the questions, so I don't have to repeat myself and all that stuff. All right. Um, so first question that'll be on the test is a quadratic, and we have to solve for x or r or a or b, the variable. We have to solve for when that variable makes the thing equal to zero. All right, and I actually I crossed this one out just because it's a bad example. That's a little bit too easy than what I would want. Um, so I made up a new one. All right, 3x squared minus 17x minus 28 is equal to 0. And the directions say to solve this equation by factoring. All right, so you can do this a number of ways. I like to use the box. You don't have to. Um, it just helps me out. It helps me think. Okay, so in this box, 3x squared goes top left, negative 28 goes bottom right, and we need factors of 3x. So the only ones that work are 3x and x. Right, so 3x is this length right here and this length right here. Okay, x is this length right here and this length right here. All right, so that's we're taking areas here, so that's why I'm making sure we understand which length is which. Actually, I could just do this. So those ones are easy because that one's prime. But then we need factors of negative 28 such that when one of the factors is multiplied by, 3x, we get negative 17x inside each of these two. So I'll do that in a different color. Let's do that in something different. Let's just do pink. All right. So factors of negative 28. I'm going to try, let's say negative 7 and positive 3. Okay, so negative 7 times 3x, that's negative 21x. X times 3, that's 3x. 21x plus 3x. Sorry, negative 21x plus 3x. That doesn't quite work. That should be 4, that's why. Alright, so this should be plus 4x. Okay, so negative 21x plus 4x gives us negative 17x, and that gives us this middle term right here. Okay, so we know that these factors work. All right, so our factors here are 3x plus 3x plus 4. That 4x shouldn't be there. and x minus 7. Okay, and we can check this. We can FOIL this back out, right? 3x times x, that gives us 3x plus 2, 3x squared. 3x times negative 7, that's negative 21x, plus 4x, that gives us negative 17x, and then minus 28. All right, so we can check this just by FOILing it back out. And we know that this thing is equal to 0. Okay, so this factoring, right, getting to here, that's only about half the problem. All right, what we have to do is we have to actually solve for x. Okay, so if we have a factor of two things that's equal to 0, then one of those two things has to be equal to 0. So we set both equal to 0. And then we solve. Okay, so we get both of these values. Okay, I'm hoping this one is straightforward. We practiced this quite a bit, and I know a lot of you did this last year or the year before or whatever. But this is just an example. Okay, so I'll try and leave this on the screen, but I want to move on to the next one because I want to get to stuff that people might struggle with, like completing the square. It's really hard to hear what you're saying. Okay, I'll turn myself up. I hope this helps a little bit. Sometimes it's just how the mic works. Let's try that. That looks like it sounds better just off the feed. I'm gonna assume it does. Okay, because it's not clipping, but okay. That's better. Good. I tested this before and it seemed fine, but that's fine. All right. So that's how we do the factoring. I'm hoping people at least follow along with that problem. And luckily, it's not anything crazy hard to do. We just kind of follow that algorithm and we get our answer, right? It takes a little bit of guess and check, right? So these two values right here, a little bit of guess and check, because they have to add up to rather these areas need to add up to negative 17x. Okay, so I'm hoping we covered that well enough in class that I don't have to go back over that. All right. The next one, solve each equation by using the quadratic formula. Okay, we should all know the quadratic formula by now. That formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and all we do is we identify a, b, and c, plug it in, and simplify as much as we can. All right, so in this case, we get negative 10 plus or minus the square root of negative 10 squared minus 4 times a, so 9, times c, so 11. All over 2 times 9. And then we're just simplifying. All right, so this is a little bit messy because I put this up here. Oh well. So we get 10 plus or minus 100. It is math time, Mason. Thank you. 4 times 11, that's 44. 44 times 9, that's 36. 396. All over 18. Okay. And then when we do this, we get 10 plus or minus the square root of negative 296 over 18. And then we have to factor out, we have to factor this negative 296. Okay. This is going to take me just a second. So 296 numbers that go into that. So if we factor out a 2, so I'm gonna rewrite this in different factors. So we can rewrite this as the factor of -1, 2, and 148. I realize these aren't perfect squares, but I'm trying to get it to that. Okay, and then we have then we have 10 plus or minus. Let's just do this. I gets rid of the square root of -1. We can factor out another 2. And then we have 124. Sorry, 99, no. 48 divided by 2. 74. So I think there's a better way to do this. Sorry, I haven't seen this problem yet, so I didn't actually look at it. 296. Okay. So we can factor out a 4. So I'm still going to write this as -1, 4, and looks like 74. Okay, all over 18. So when we simplify this, we get 10 plus or minus 2i rad 74 all over 18. Okay, and for now, that's your best answer. 74, I don't think you can reduce, at least not easily. No, you cannot. All right, so then that's our answer. Okay, so just things to know, things to remember. This square root of -1, this is just I. And then we can split up big factors into smaller factors such that we can get a perfect square, right? So the perfect square that we got out of here was 4. So we rewrote -296 as the square root of -1, square root of 4, and square root of 74. Is that the answer? Yeah, that'll do for the answer right now. Okay. If you remember, IXL had you like kind of split it up. I'm not super concerned about that. If you wanted to simplify that, you could. In fact, if you got 5 plus I rad 74 over 9, I think that works. Okay, but you don't have to go that far. I just want you to be able to simplify the radical as much as you can, simplify that square root of -1, and then you use the quadratic formula. That's really what I'm worried about. My hope is that you guys have seen, you know, you can reduce fractions a little bit. Okay, so this will be our answer for now. Okay, next one, 10r squared plus 7 is equal to -54. This says solve each equation by using square roots. All right, so when there's just r squared and there's nothing else, all you gotta do is get r squared by itself and then take the square root of both sides. Okay, so if we do that, we get 10r squared is equal to -161. Yeah. Divide by 10. So we get r squared is equal to -161 divided by 10, and then we take the square root of both sides. So r is equal to plus or minus the square root of 161 over 10, of -161 over 10. Okay, and I think 161 is prime. So we're going to leave that there. Okay, so we're going to simplify this a little bit. This is plus or minus the square root of -161 over the square root of 10, which is I rad 161 over the square root of 10. Is this live stream being recorded? Yeah, it normally takes just a little bit of time to get back up. So if you just kind of leave the page open, that's probably the best thing to do. What does prime mean? Prime means it doesn't have any divisors other than itself and 1. That's not a word I normally used, but that's not a word I used in class. It just means that you can't reduce it. Okay. Now, we simplify the square root of -1. That's where this I came from. All right. Now what we need to worry about is the rationalizing. Okay, so we can't have square roots in the denominator. So think of this as like part 2 of the equation. Okay, so what we need to do is we need to multiply that I rad 161 over rad 10 by rad 10 over rad 10. So you get rad 161, I rad 161 over rad 10. And we need to multiply that by that clever form of 1, rad 10 over rad 10. Yeah, you'll be able to watch later. It should just kind of show up on the page. It might take a little bit of time to watch it, but yeah. Okay. Then if you just reduce this, you get I rad 1610 over 10. And I think we'll stop there. We can stop there for the answer. Okay, because then it just gets a little bit obnoxious. There should be a plus or minus. Okay. So really what I want you to be able to do is use the square roots. The question that I give you should work out a little bit better than that. I think this one I regenerated was a little bit obnoxious with this stuff, but that's okay. The idea is the same. Okay, I want to pause before I scroll down and show completing the square. So are there any questions over 2 or 3? All right, I'm taking that as a no. Keep in mind you can always like rewind and stuff. You don't have to listen to it live. But I'm going to move on to 4 and 5. All right, so find the vertex of the following by completing the square, i.e. convert to vertex form. All right. So this is probably going to take a little bit more room than I gave on this. I made this a little bit shorter so I could fit it without being obnoxious. But that's okay. So let's give us some space. Well, all right, whatever. All right, so completing the square. So what we need to do is we're just worried about these two terms right now. Okay, and in vertex form, which I'll write over here, right, that's vertex form, where the vertex is HK. But what I'm focused on is what's inside parentheses and right before the x. Okay, the coefficient of x inside the set of parentheses is 1. So what we need to worry about is we need to factor out this 9 from these two terms. So if we do that, we get 9 times v squared minus 2v, and then everything else just stays the same. And then we need to complete this square inside the set of parentheses. All right, so I'll make our box, which is going to look a little bit small right now. All right, so v squared, so v and v. These two boxes, right, those have to add up to negative 2v evenly. So this is going to be negative v, this is going to be negative v, which means these are negative 1 and negative 1. So our factors here, we're going to have 9 times v minus 1 squared minus 86 is equal to 8. but we added a plus 1 inside this box, which shows up inside the set of parentheses. And because it shows up inside that set of parentheses, right, if you were to FOIL out v minus 1 and v minus 1, you'd have that plus 1 there. But all that is being multiplied by 9. So what we did is we added a plus 9 to the entire left-hand side of the equation. So in order to even that out, in order to balance it out, we have to add 9 to the right. And then all we have to do is get everything to the left. So we get 9 times v minus 1 squared. 8 plus 9, that's 17. Negative 86 minus 17 is negative 103. Okay, so our vertex then is 1, negative 103. Okay, so I want to make sure people kind of understood what I was doing. So if you have questions over anything in red or that little bit in blue, please ask. All right, so I'll give you a second to kind of look it over and make sure that made sense. Where did I get the plus 9? All right, so let's see if I can make this a little bit clearer. All right, we're completing the square in green. All right, so when we do that, all of this is going to be in green as well, right? That's just kind of highlighting what we've done so far. Now, if you look in front of the green, it's all being multiplied by 9. Okay, so this entire thing is in parentheses with a 9. Okay, the bit that we added is that 1 inside this box. Okay, because we added the 1 inside the box, we added 1 inside the parentheses. So because we added 1 inside the parentheses, that 1 is really being multiplied by 9. Okay, and we didn't just add 1 to the left-hand side, we added 9 to the left-hand side. So because we added 9 to the left-hand side, we have to add 9 to the right-hand side. I hope that makes sense. So in the vertex form, you change the sign of the 1 in the equation. No, you don't change the sign. The reason it's positive 1 is you're multiplying this negative 1 and this negative 1. Right, so you're not really changing the sign. It just happens that we're multiplying two negatives together. Okay. I want to go on to the next one just so people can see it. All right. And I'm going to do this somewhere different so I have room to kind of show you. So 6n squared minus 12n equals 5. Okay. So same problem, just different place. When we are completing the square, we are only worried about the two terms with n or our variable attached to it. So for us right now, that's everything on the left-hand side. So the first thing we need to do is we need to make sure that there is no coefficient of n squared. So we have to factor out everything in front. In that case, it's just that negative, it's that positive 6. Okay, so we're going to factor out the 6. And then what's left is n squared minus 2n. Everything else stays the same. So our job is to complete the square inside this set of parentheses. All right, so if we have a square, all right, everything in white is the stuff inside the parentheses, at least on the left-hand side, and then outside there's that 6. Okay, so everything we do inside, we're going to have to be multiplying by 6. Okay, so up top we have n squared. The factors of n squared are n and n. And then we need these two boxes. We need those to add up to negative 2n. And those need to do that evenly, right? So negative n goes up here, and negative n goes down here. Okay, so keeping in mind that if this length is n, this length up top has to be negative 1, right? Because negative 1 times n gives us negative n. And then same thing down here. So if we do this like an equation, we get that so far. Okay, now what we didn't do is we didn't add this part of the equation yet. All right, so if we add that part of the equation, right, negative 1 times negative 1, that's just positive 1. And now that part is being added to the left-hand side. Okay, but we're not just adding 1 in this case. We're adding this 6 times this 1. So we added 6 on the left, so we have to add 6 on the right. Okay, so what we get is we get 6 times n minus 1 squared is equal to 11. All right, and then we just get everything to the left, and we're pretty much done. Okay, so we get 6 times n minus 1 squared minus 11, and then this is our equation. Okay, so the vertex of this is hk, so we get 1, negative 11. So again, I want to pause for a second and make sure people understand what just happened. Okay, it seems like no one has questions over that. All right, I'll come back to this a little bit later, but this is one of the harder parts just because there's a couple of moving pieces. Okay, bottom line, if you understand like this box, if you understand how to do that and what that means, you'll be fine. Okay, we practiced this quite a bit, so go back to your notes, go back to the homework. You have a bunch of examples of stuff like this. Okay, so that takes care of the second completing the square problem. All right, so let's move on to the rest. So next question, question 6, says to find the vertex of the following. Okay, so we need to get vertex from standard form. So vertex from negative x squared plus 4x minus 3. All right, we need to know, first we need to get the axis of symmetry, right? So the axis of symmetry is just negative b over 2a. and then we just plug in stuff, right? So b is 4, a is -1. So we get 4 over 2 times -1, which is just altogether -2. Is there a way to check these answers on our calculator? Yes. All right, if you know what you're looking, you're like in the last two questions, we were trying to find the vertex, right? So you can plug in the original equation. You can do second calc or second trace, and then identify maximum or minimum, and then follow the prompts on the calculator. Okay, if you do that, you'll basically verify your vertex. All right. So moving on from this, right, we get the axis of symmetry. That's negative b over 2a. And then in order to get the second part of the vertex, we just plug that in, right? So -2 squared plus 4 times -2 minus 3, and that gives us the second part. So 4 minus 8 minus 3. So -4, so -7. So our vertex for this is -2, -7. Yes, it should be -4. So that changes things. Yeah, so it's negative b over 2a, so this b should be negative. So -4 over -2, which is just positive 2. Right, so I did that wrong. Then we plug that back in. So -2 squared plus 4 times 2 minus 3. So -4 plus 8 minus 3. So we just get 1. So our vertex is 2, 1. I hope that's straightforward. That's one of the first things we did. We found the vertex in standard form. That's literally like the first thing that we did with this chapter, right? In order to do that, we do negative b over 2a. You get an answer. You plug that answer back in, and that answer, and that second answer gives you the vertex. Okay. So I'm gonna move on. Sketch the graph of each function by finding the vertex and the zeros. If there are no zeros, find the imaginary zeros. Okay. The first thing I'm going to do is I'm going to find the vertex. Okay, so when we find the vertex, that's negative b over 2a, just like we did up top. So that's -8 over 2 times -2. That just gives us 2. So if we plug that back in, so that just gives us positive 4. So our vertex is 2, 4. Okay, so that point right there, that's our vertex. We know it opens down because of this negative. And then we need to find the zeros. Okay, so we know it's going down, so we know it's going to hit 0. Our job is to find that. Okay, so I'm going to try and factor this. And the first thing I'm going to do, I'm going to pull out -2. And what's left is x squared minus 4x plus 2. And we're setting that equal to 0. Okay, so if we factor the thing inside, we can't fix that. There are no factors of 2 that add up to -4. So we're just going to use the quadratic formula. All right, so negative b, so -8 plus or minus the square root of b squared minus 4 times -2 times -4. All over -4. Simplify this. 64 minus 32. And then we simplify that 32. So that's negative 8 plus or minus the square root of 16 square root of 2 over negative 4. So negative 8 plus or minus 4 rad 2 over negative 4. And to simplify this, just to make sure we get an actual point, this is negative 2 plus or minus rad 2 over negative 2 over 1. Yes, this entire thing is negative. So let's just do that. Okay, what I'm doing here, I found the vertex. I use the quadratic formula to find the zeros. Okay, now 2 plus or minus rad 2 over negative 1. It doesn't look like a point that's directly on the, like in a clean spot on the x-axis, but we can just find it. So negative 2 plus rad 2 divided by negative 1. That's like a half. And so that's like right here. And then negative 2 minus rad 2 divided by negative 1 is like 3.5. All right, and then we're done really. We just got to connect the dots. Okay, so that's what our graph will look like. If we want to be really specific, I guess we could also get a y-intercept. Should be right there. So it'll look like that. Okay, so find the vertex. That part should be easy. That's negative b over 2a. Again, all of this you can do in a calculator as well. And then you can either factor or use the quadratic formula to find the zeros. So that's that part in green. Okay, so I want to pause there for just a second, make sure that makes sense, and then we'll move on. Also, this next like little bit, this will probably take a little bit less time. So if you're being impatient, that's okay. Just give it a minute. I started out foiling and then used the quadratic formula because what happened is if you factor out a negative 2 from everything, which I like to do just to keep this clean because there's a factor of 2 and everything, you get this, right? So what we need to do is we need to FOIL the inside here. And we don't have any factors of 2 that add up to negative 4. That's why I stopped foiling, or factoring. Right, I couldn't foil it. I couldn't factor it fast. So if I can't like immediately factor something, I just go directly to the quadratic formula because I know that's like systematic, and it always works. So there's no reason like not to do it rather than struggling on a factoring problem, which in this case you can't do anyway. All right. I want to go on to this next part, which a lot of this is going to be pretty straightforward, because it's stuff that we've kind of already done, at least in this test. Square root of negative, so simplify the following. That's the whole goal of this. We just need to simplify or rationalize. All right, so square root of negative 120. I'm going to write this as square root of negative 1 times the square root of 30 times the square root of 4. Okay, and when we do that, we get I rad 30 times 2. So this is equal to 2I rad 30. And there's no other perfect square stuff that you can take out of 30. So then we're done. If you want to be really specific, there should be a plus or minus here, but and just 2I rad 30, that'll work. That gives me the answer. Number 9, all we're doing is combining like terms, right? So 7 minus 6, that's 1. 3I minus I, that's just 2I. And that's that. Number 10, we've got to FOIL. So we do negative 1 times negative 2. That's 2. Negative 1 times positive 7I. That's negative 7I. Negative I times negative 2. That's plus 2I. And then negative I times 7I is negative 7I squared. We simplify a little bit. 2I minus 7I plus 2I, that's 2I minus 5I. And then negative 7I squared just becomes negative 7 times negative 1. All right, and then we just simplify, so 2 plus 7, that's 9, and then we have 9 minus 5I. So that's, the harder one probably on this one, but all we're doing is foiling, and we have to keep in mind that I squared, that's always going to be equal to negative 1. All right, if you understand that fact, this part should be pretty straightforward. Okay, so we go down to a number 11, and we kind of do the same thing, except we're just distributing. All right, so if we clean this up a little bit, we get 14I times 4 minus 4I. So 14I times 4, that's 56I. And then minus 56I squared. Minus 56I squared is just positive 56. So we just get 56I plus 56. I to the 13th. So this is that cycle, right? So I is just equal to I. I squared is negative 1. I cubed is negative 1 times I, which is just negative I. And then I to the 4th is just 1. And then it repeats that cycle. So every 4, you come back to 1. Right? So I to the 13th, that's I to the 12th times I. I to the 12th, if you want to think about it this way, you can. That's I to the 4th times I to the 4th times I to the 4th. And then we have this I on the outside. So this is 1 times 1 times 1 times I, which is just I. Or you can know that I to the 12th is also 1. Okay. 13 through 16 have to do with rationalizing. Number 13 and 14 are like the easier versions. Number 15 and 16 are like the quote unquote harder versions, right? So on number 13, these are going to get bigger numbers than what I wanted, but that's okay. We have to get this square root of 35 out of the denominator. So we have to multiply by the square root of 35 over the square root of 35. When we do that, we get 9 rad 6 times rad 35 gives us rad 210 plus 5 rad 35 times 3, and then over 10 times 35, which is 350. Okay, we can stop there, especially with these really big numbers. I'm okay with that. Okay, that is rational for me. All right, in number 14, our goal is the same. We just got to get the I out of the denominator. So we have to multiply by this clever form of 1 of I over I. So if we distribute that, we get 6I, and then minus 5I squared becomes plus 5 over 3I squared, which becomes negative 3. On number 15, whenever we have a sum or difference, like 9 plus 2i or 10 minus rad 5, we've got to multiply by a conjugate. Okay, so in this case, we multiply by 9 minus 2i over 9 minus 2i. It's the conjugate of the denominator. All right, so if we FOIL that, negative 3 times 9, that's negative 27. Negative 3 times negative 2i, that's plus 6i. 10i times 9, that's plus 90i. 10i times negative 2i is negative 20i squared. Then we FOIL the bottom, and when we do that, we get 81 minus 4i squared. And then when we simplify that, negative 20i squared becomes positive 20. So we get negative 7 plus 96i over 81 and then plus 4. That's 85. So this is our answer. Do the same thing on 16, which is multiply by 10 plus rad 5. And the idea is the same, right? So negative 1 times 10, that's negative 10, minus rad 5, plus 10 rad 7, and then plus rad 35. On bottom, we get 10 times 10, that's 100, and then it should be minus 5. Simplifying, everything on top stays the same. Ten minus 5 is just 5. So I want to let people look at these four for a second, just make sure there are no questions, and then I'll move on to the last two. Why is the second 10 positive? Like the 10 in the denominator? Or this 10? I think you mean the 10 in the numerator. On number 16 on the top. 16 on the top. So if we FOIL, negative 1 times 10, that's negative 10. Negative 1 times rad 5, that's negative rad 5. Positive rad 7 times positive 10, that's positive 10 rad 7. And then the same thing, rad 7 times rad 5, that's rad 35. Okay. I want to move on to 17 and 18 just so people have a chance to ask questions over anything else. 17 is just like the one we did a couple of these in class, and I also gave you one for the practice test. Actually, this one might be the same, but I want to go over it just to make sure we understand it. Okay. I'm going to give you some point that you can actually use. So whether that be 2 zeros, so it would be x comma something 0, or I'll give you like a y-intercept. All right, in this case, I'm going to give you the y-intercept. Okay, so because of that, we know that in our standard form equation, we know that c is going to be negative 2, right? Because if we plug in 0 in for x squared and x, we're just going to be left with that y-intercept. And then we have to use the other two values in order to solve for a and b. Okay, so we get two equations. We get 7 is equal to a times 1 squared plus b times 1 minus 2. And we also get negative 3 is equal to a times 4 squared plus b times 4 minus 2. Why is negative 2c? So negative 2 is c because we are given this y-intercept. Right, so if we plug in 0 for x, we should get out negative 2. Right, so in a standard form equation, if we plug in 0 for here, 0 for x, right, ax squared is 0, bx is 0, and we should just be left with negative with c, right? So 0 should equal, whoops, no. Negative 2 should be a times 0 squared plus b times 0, and then plus c, right? So these cancel out, so you're left with negative 2 is equal to c. All right, so if we kind of simplify these two equations down here, if we bring the negative 2 over, we get 9 is equal to a plus b, and we get negative 1. Oops. Negative 1 is equal to 16a plus 4b. And then we have a system of equations which we can solve. Okay, so I'm going to write this on the right. And you can solve this in any way you want. I'm going to multiply the top by negative 4. So we get negative 4a minus 4b is equal to negative 36. And then we had our original 16a plus 4b is equal to negative 1. Use an elimination, right? We get 12a is equal to negative 37. That's a little bit dirtier than what I wanted. And then a is equal to negative 37 over 12. Is that right? I thought I made this a little bit cleaner, but I guess not. Okay, so then we use A to find B. Right, so we can have negative 37 over 12 plus B is equal to 9. If we add that 37 over 12 to both sides, we get B is equal to let's see, 108 over 9, or sorry, over 12 plus 37 over 12. So B is equal to, where does the 1 come from? Hold on a second. All right, so we get B is equal to 145 over 12. All right, where does the 1 come from? My guess is you mean this one. Right, so if we add this 2 to both sides, right, so we have negative 3 is equal to A times 4 squared plus B times 4 minus 2. If we add that 2 to both sides, just to solve for A and B, negative 3 plus 2 gives us negative 1. And then 4 squared is 16. 4 times B is 4B. Okay, so like our entire equation, again, this is messier than what I wanted it to be, is going to be y is equal to negative 37 over 12x squared plus 145 over 12x, and then minus 2. Provided I did all that right, which I think I did. Okay, so that's a lot. I want to just pause for a second, make sure people understand at least what is happening, right? So we're going to use 1 point to solve for one variable. In this case, right, we're given the y-intercept, so we should know c, right? That's just going to be negative 2. And then we use these other 2 points, right, 1, 7, and 4, 3, and we plug those points into that like general equation, right? So in this top case, 7 is going to be equal to A times 1 squared plus B times 1, and then minus 2. We plug in the other point. We get that negative 3 is going to be equal to A times 4 squared plus B times 4, and then minus 2 again. And then we're just simplifying, and we use both of those equations, right, this equation and this equation. We solve that system, and we get our answers. All right, this last question, I can't show you exactly how to do it, but if you have a calculator, at least on you and in front of you, I can at least guide you. Okay, so on this equation, or on this problem, right, I'm going to give you a set of data, right, which is just a set of x's, a bunch of x's, and a bunch of y's. Okay, so in order to do this on a calculator, which is exactly what I'm expecting you to do, if you hit the button stat, right, so you hit the stat button, and we want to edit. So just hit enter. We want to put all of the x's in list 1. So 20, 30, 40, 60, and 70. right? That goes all in list 1. List 2 is going to be all the y's. So 372, 462, 509, 437, and 323. Okay, so I'm just going to plug those in real quick. And once we have all of those in list 1 and list 2, you can just get out of there. So second quit. So you delete old numbers. If you're in stat and edit and you're like in the list section, if you just scroll up to where it says L1 or L2 and hit clear and then hit enter. So on L1, if you hit clear and then enter, it'll get rid of all the numbers. Okay, but after you plug in all those numbers, right, you quit, you go to stat again, then you scroll right to calc, and then we want the quadratic regression, so quadreg. You hit enter on quadreg. You just hit enter until it says calculate. Once you're highlighting calculate, you hit calculate, and then it should give you A is negative 0.2592, and then we'll just stop there. B is equal to 22.38, and C is equal to 26.79. So this problem, it doesn't require a whole lot of thinking like mathematically. I just want you to be able to use your calculator to do basically a line of best fit, right? So a quadratic regression. So that's the entire test. I'm going to definitely make a couple of changes to make your lives a little bit easier, especially on probably 17, something like 13, and 9 and 5. You'll have an easier completing the square one, and then one a little bit harder. But that's the idea, okay? So I want to kind of pause for a second, make sure people understand what's happening at least. And then if there is none, we can end in the next couple minutes. If there are, I'm willing to stay on as much as you can, as much as you need. All right, so I'll mute myself, make sure you don't have any questions, and then we'll go from there. How many questions will the test be? It'll be exactly the same length. Right, so 18. Pretty much one from each different type of question that I could ask you. Okay. Obviously, I want to stick around to make sure people don't have questions, but we'll do this. If by 8:41 people don't have questions, I'll shut this down and we'll just call it there. What I would suggest is, especially if you like just got here, maybe leave this window open because you can kind of scroll back or scroll forward or whatever, and see if I go through every question so you can see exactly what happened on which question. Do we have the whole class period to complete it? Yeah, of course. And again, I'm going to make some of this just a little bit easier. Right, so there's a couple of questions in here that as I was doing, I'm like, this is maybe a little bit hard, at least all at once. Like I would expect you to be able to do like one or two of these on your own, like at a time, but all of it together might be a little bit hard. So I might make some of these a little bit easier. But yes, you have the entire class period. Okay, so we'll call this at 8:41. If you don't have questions, if you have questions, I'll keep going. But I don't want to like stay here forever indefinitely if you don't have questions. Okay. I'll call it. Um, Again, if you have questions during advisor, if you want to ask me a last second question, that's fine. I'll also be in my room in the morning, all right? And we can go over kind of last second questions right before the test. So don't hesitate to ask me. But I will shut this down. This should be up within like the next hour or so. I hope it'll just kind of show up on the page. I don't have anything to do with it. I don't put it up. It just kind of, I guess, uploads itself. So if you do have questions and you don't want to wait, I would suggest keeping this window open. All right. So I will call it here, and I will see you guys tomorrow. Thank you for asking questions if you had them. If not, I'm happy to answer them whenever you need. All right. So I'll see you guys tomorrow. All right.